strict problem of LeetCode, ones and zeros. You are given an array of binary strings strs and two integers m and n. Return the size of the largest subset of strs such that there are at most m zeros and n ones in the subset. And a set X is a subset of set Y if all elements of X are elements of Y. So simplifying this problem statement, an array is given, an array of binary strings is given along with two integers m and n. M represents the count of zeros, n represents the count of ones. We are required to calculate the largest possible length of the subset in which there are at most m zeros and n ones. Now let me switch to my notepad. Okay. Let me take this one. Now let's solve this problem with a practical analogy. Let's say you're going on a trip, and for the trip you are packing your bag, and in that bag you have to pack shirts and t-shirts. The condition in this problem, in this analogy, is, say the bag has a capacity of m shirts and n t-shirts. Here you have to pack till the maximum capacity of the bag, but the count of shirts should not exceed this m shirts, and the same way the count of t-shirts should not exceed this n t-shirts. Another time you have to pack maximum number of outfits in the bag. Shirts and t-shirts combined together, we call it as outfit, right, in general terms. So you have to pack your bag with maximum number of outfits possible by following this strict condition: at most m shirts and at most n t-shirts. At most means less than equal to m shirts and less than equal to n t-shirts. Now for packing this bag, I have two choices. The first choice is skip the present choice. Suppose I visit a choice, it's either a shirt or t-shirt, and I'll pack my shirt or t-shirt based on my preferences. Suppose the t-shirt is the t-shirt is oversized, I will avoid it, or I can pack it. The shirt is oversized or another one, I can still avoid it. So the first one is skip the present choice, and the second choice is select the choice. Now when I see the shirt or t-shirt I'm about to pack in the bag, I have my preferences of selecting it. Like, I prefer the color, I prefer the type of material, and many parameters. Now if I take choice 1, the first choice is skipping the present choice, the result will be the capacity remains the same, right? The capacity is same. There is no effect in the capacity. Now if I select the second option, the result will be reduce in the capacity count. Obviously, if I select a t-shirt or shirt and for the next iterations or next choices, I observe the reduce in the capacity, right? Here, the main question is, if I select an outfit, will it maximize my output? If I select a shirt or a t-shirt, it must contribute to the maximum output. Here the maximum output is I have to pack my bag with maximum count of outfits. So as I told, this is an analogy. You can connect it to the problem like shirts represent the count of zeros and t-shirts, sorry, it's t-shirts represent count of ones. Just remember this line. So this is the main idea. Once again, I'm going to tell the main idea. If I select a choice, if I'm iterating a choice, I have two options, either to skip the choice completely or to select the option. If I skip the option, my original count is same, original capacity count is same. If I select the option, the result is for future options I observe a reduce in the count of options. Now we have discussed the main idea behind this problem. Now how do we solve it? Using the approach of dynamic programming. So what is dynamic programming? Dynamic programming is, as we discussed above, we have two choices. We iterate both the choices compulsory, iterate both the choices, and the main advantage, which is a twist in dynamic programming concept, is we avoid recalculating the same choice repeatedly, and it mathematically reduces the need of revisiting the same option repeatedly in many iterations, in future iterations. So this is the main idea of dynamic programming. Now how do we approach this question? In dynamic programming, we create a 2D table. It's similar to creating a 2D array. Now say the table is, this is the 2D table, similar to declaring and creating a matrix. Now here I represents the count of the count of zeros, and j represents the count of ones. And when I represent the constraints in the terms of dynamic programming equation, I write it as dp of ij. This one represents the present choice and the choice is skipped. To simplify this one, let's take a mathematical coordinate. A coordinate x comma y, or simplifying, it's I comma j. Here, as I told, I represents the count of zeros, j represents the count of ones. This represents the choice is skipped. Now what is the representation for second option? Like I have written the equation for skipping the present choice. Now how do we represent for selecting the choice? What if we select the current option So the entire dynamic programming concept is present plus past. To be precise, we connect the choices of present with the results of past. We store the results of past so that we don't need to revisit the past iterations completely, and representing it in dynamic programming equation. The core idea of dynamic programming is here dpij is my present choice, my present state to be precise, and 1 plus dp of I minus zeros and j minus ones is the past. We are combining the idea of connecting the present choice with the past. So let's get into solving this problem with dynamic programming concept. And here this is my array of binary strings, and this represents the count of zeros, the maximum count of zeros, the maximum limit of ones I must have in the subset. Also, here the order doesn't matter. You can select your choices in any order, but the output should be maximum by strictly following these limits. Say, let's iterate for each and every binary string. Now say coordinates. In coordinate A, in the first element, in the first binary string, I have 1 0 and 1 1. So if I represent it in coordinate, I get A is 1 comma 1 and B is, say, I get 3 zeros and 1 time 1. So it's 3 comma 1. C represents 3 times, sorry, it's 2 times 0 and 4 times 1. So it's 2 comma 4. And D represents the 0 has occurred for 0 times and 1 has occurred for 1 time. So it's 0 comma 1. And for E, it is 1 times 0 and 0 has not occurred. So these are our coordinates. These are our coordinates representing the frequency of zeros and ones in each and every binary string we iterated. Now, this dynamic programming deals with a 2D table. Say it's similar to matrix, like say uh, say this one is J and I. This J is from, J represents the column and I represents the rows. Now both start from 0 and we have in this question 3 ones. So J represents the count of ones and I represents the count of zeros, and here I'm representing I as rows, row wise iteration. Now 1 and 5. Now I fill it here for the first coordinate 1 comma 0. It's 0 here and 0 overall for I equal to 0 and j equal to 0 or 1. First let me fill this up and then explain why it is and how it is. Just give me a moment. Okay, here this is j and this is I. Please don't mind for the cell representation, as this is a notepad interface. There is no other option to write it in a direct way. And getting into the problem, since the strings are binary, 0 represents yes, 0 represents false, 1 represents yes, true. So in this 1 comma 0, in the string 1 0 and the coordinate 1 comma 1, whenever I value is equal to 0 or j value is equal to 0, that specific index 0, like take it as, to be general, take it as matrix of 0 0 will be 0, or for I values equal to 0 or j value equal to 0, the value will be 0. Now every cell with I greater than equal to 1 and j greater than equal to 1 becomes 1. So as I explained this one, if either j is equal to 0 or I equal to 0 or both are equal to 0, I fill that specific location with 0, and this one here is the same. And this is the table, this is the 2D dynamic programming table which we get. Here we have developed the table, we have created a table for one coordinate, only one coordinate. We have to design the table, we have to create the table for the other coordinates also and select the optimal choices from them. Now say for process B, the coordinate is 3 comma 1 and 3 comma 1. Here every cell with I value greater than or equal to 3 and j value greater than or equal to 1 will have this values. Now that simplifies our iterations. This is the main idea of dynamic programming. See, once again I'm repeating, I value greater than or equal to 3 or j value and j value greater than or equal to 1. So we need not start from I equal to 0, j equal to 0, I equal to 1, j equal to 1. We can directly start from 3, I equal to 3 and j equal to 1. So let me do it directly. For dynamic programming, here max of 1 plus 1 comma 1 plus dynamic programming of and here I get 2. So similarly max of 1 comma 1 plus dp of 1 comma 2. How did we get this one here? It's from the previous computational result, previously calculated result, or this is from the present choice. This one is present in the present choice. This is the present state condition in dynamic programming iteration, and this one is the past. We are revisiting the past results. We have already calculated the past results in previous iteration. Now we are directly using them. So here keep on calculating for 5 comma 2 and dynamic programming 5 and 3. We have reached the limit. The maximum limit of zeros is 5 and maximum limit of ones is 3, and the updated updated maximum is 2. Since we get 2 in every dynamic programming equation result. Now same for C. In C we have 2 zeros and 4 ones. So we directly eliminate this coordinate, because the maximum limit of ones which we must have in the subset is 3, but here we are having 4. Eliminated any subset, any coordinate which is exceeding the maximum limit should be eliminated, and this is another core principle of dynamic programming approach. And directly skip to D, the coordinate D 0 comma 1, and here it's the same. Use the equation of dynamic programming of ij, and from this we take the maximum of present state condition and past state condition. Past state is so we add D, the coordinate D, and the binary string linked with D, because it's still following the maximum limit. It's not exceeding the maximum limit, which is 1. We add this one to our subset, and similarly the E, the coordinate E, because it's still within the maximum limit. And it's the same. This equation, dynamic programming is all about this equation, calculating and computing this equation. Now optimal subset, the resulting subset. String 10, we add the string 10, we add the string 0001, we exclude the third string, and we add the string 1 and 0. So these are the strings, binary strings, which we add in our resulting subset, and as a part of verification, like what is dynamic programming, did dynamic programming successfully solve this problem? Let's have a simple verification. In 10 we have 1 0 and 1 1, and in 0001 we have 3 zeros and 1 time 1, and in 1 we have 0 times 0 and 1 times 1, and in 0 it's the opposite of the previous case. We have 1 times 0 and 0 times 1. Now add all this, add all the I coordinates in I place and j place separately. Here 1 3 and 1, which adds up to 5, and for j it's 1 1 and 1, which adds up to 3. So dynamic programming has successfully solved this problem by following the maximum limit conditions and at the same time maximizing the subset, the length of the subset. So once a small review of this problem, dynamic programming is all about connecting the present state condition to the past results. We store the past results in our memory and directly use the past results in in calculating the maximum output. Here we calculate the present and past conditions and take the maximum of both the output. dpij is present state, like the choice is yet to be selected or skipped, and this is past choice, the past results. So this is all about dynamic programming. Thank you.